Hey guys, this is Vignesh from BreVITy. Today we are going to code the longest substring without repeated characters on LeetCode. This is the C coding tutorial for this video. We've already covered the template code in sliding window intro video. Our friend Siddarth has covered this question in great detail and explained it very well. I'll wait until you watch that video. Done? Okay, let's get started. Okay, the question goes something like this. Given a string S, find the length of the longest substring without repeating characters. We've seen this keyword before, longest substring. We can instantly connect it with the sliding window technique that we've been learning. We'll be using our usual 5-step process to solve this question. Let's get started. Step 1. Implement the logic. We'll need 2 pointers. L and R demarcates the start and end of the sliding window. L represents the left boundary and R represents the right boundary. Now we can start with the expansion phase. This expansion phase will be working when test condition is satisfied. Now what if the test condition is not satisfied? In which case we'll have to start the contraction phase where we'll be moving the left pointer. Okay, but here the test condition requires that the window does not contain duplicates, which can be represented using an intermediate memory called unordered set memory. The test condition is that it should not contain duplicates. That is, we can use this function mem.count. Here the set will count the occurrences of a given requested character. Count can either be 0 or 1 because the set does not store duplicates, and the compiler assumes 0 to be false and 1 to be true, or any other number to be true. So we can use a shorthand to simplify it from, instead of this we'll be writing .count to simplify the syntax. During the expansion phase we'll be adding the elements which is present at the right pointer into our memory, saying that this element is present in our set. We can do that by doing this and then move the right pointer. In the contraction phase, the exact opposite occurs. While a given element is present in the set, we'll be moving the left pointer and then removing it from the set, which can be done like this. Now, after this contraction and then adding the current element, we'll have a window. Now this window will need to check if this is the maximum valid window. To do that, we'll need another variable called mx, which will be initialized to 0. mx is max of mx comma. We'll be using this syntax to find, after the expansion contraction phase, we'll be left with a valid window. We'll be using this line to check if this is the longest valid window or not. And finally, we'll return the value mx. As you can see, it works. Let's try submitting it. As you can see, it works very well. That's the end of step 1. Step 2. Adding edge cases. The beauty of implementing sliding window like this is that it takes care of its own edge cases. You don't have to add extra if conditions or extra clauses to make it work for the edge conditions. We can go to step 3. Debugging. We haven't currently encountered any errors, but if you have an error, you'll be doing that during this phase. We can go to step 4. Step 4. Optimization. Boy oh boy, is there a lot of optimizations. There is always the regular post increment that we usually do to make the code much more cleaner to the eye. Apart from this, there is also something else that we can implement. But let's see first why we're going to do that. As we have discussed in the C STL video, unordered set has O of 1, that is constant time complexity for insertion, updation and deletion. There's 2 problems with that. 1. It is not always O of 1. It is amortized to O of 1, that is, on an average it has constant time complexity for insertion, updation and deletions. Sometimes it might also have O of n. Secondly, O of 1 might still mean that you're doing 100 operations every single time the function is called. It is technically O of 1 constant time complexity, but it's still heavy on the program execution. How do we optimize that? Luckily for us, the input range is limited, that is capital A to capital Z, small a to small z, and a few special characters. We can use something like a vector of bools, where you can use the ASCII value of the characters mapped to a given index and then mark it off as true or false depending upon if it is present inside the window or not. Something like this. A has an ASCII value of 65. B has an ASCII value, capital B has an ASCII value of 66. But you can subtract it with 65 and map capital A to 0, capital B to 1, and so on till Z is marked at 25th index. The problem with this is that you can now create a vector of size 26, but we also have small characters and special characters too. How do we tackle that? To tackle which, let's look at the ASCII table first. God damn it, Whitehead Jr. With that blocker finally in place, we can stop seeing Chintu from Whitehead Jr. for 2 full minutes. Let's get back to what we were doing. As you can see, capital A has an ASCII value of 65 and small a has an ASCII value of 97. So, and also the special characters are present that is here. There is also space, exclamation, numbers, and other special characters that we need, which is present here. So we'll have to cover all these 3 full columns while we're doing that mapping from a character to an index. It starts at 32 and ends at 127, which gives us 64, 96 elements that we have to map, where space will become the 0th index, exclamation first index, and so on till 127, which will point to the 95th index. Let's get back to coding. So our mapping currently looks something like this. 0th index is actually representative of the character space. The first index is actually representative of the character exclamation, and so on. And how do we achieve that mapping? Given any character S of R, let's say, we'll subtract 32 from it, or space, whose ASCII equivalent is 32, to obtain our current mapping, which is the index. It will now give us the index. Let's create a vector of bool and explore this further. We'll call it memory and it will replace the previous one. Yeah, it is meme. Now, meme is of size 96 and all of it has been initialized to false. Let's say S of R currently contains the character space. How do we deal with this? Now, space has to be subtracted with 32 or the character space, such that it will now point to 0th index. Now, when meme of 0th index is true, then it means that the space is present in our current window. If it is false, then the space character is not present inside our current window. That's how we are going to be proceeding. Mem.count is unordered sets API. So we'll have to replace that with whatever we've discussed right now. Similarly, while removing, we'll just mark that position as false. That's it. As you can see, it is incredibly fast. But there is one final optimization that we can do. No. Don't click away. Just 1 second. Just one last word.
Get over here!
C STL also provides something called bit set. Here, we'll have to define a bit set of size 96. Difference between bit set and vector of bool is that bit set size is fixed. Unlike a vector, you can't change it after the compilation takes place. Also, it is implemented using ints. So accessing and switching is very, very fast. And all of them has already been initialized to false. Let's see how it works. It has the same API, hence you can use false or true. As you can see, it is incredibly fast. Thank you for watching. That's all for today. Stay tuned for more videos. and subscribe to our channel